We have one more thing to look at with radicals as we are dealing with arithmetic. We've done addition, subtraction, and multiplication. Last, I want to look at dividing radicals. And a nice rule that allows us to divide them. Let's consider two different problems. First, let's look at the square root of 36 divided by the square root of 4. Now, order of operations says that we want to evaluate the square roots before doing the divisions. So the square root of 36 is 6, the square root of 4 is 2, and then we can divide, giving us 3. But let's also look at the square root of 36/4. Here, that radical acts as a grouping symbol, and we need to do the division before we can evaluate the square root. 36 divided by 4 gives us 9, and the square root of 9 gives us 3. We see that we end up with the same answer whether we evaluate the square roots and then divide, or whether we divide first and then evaluate the square root. Now, this could be a coincidence. However, if you try this with other numbers, you'll get the same result, namely, you'll get the same numbers for each of them. And so hopefully it's fairly easy to believe that we have a rule. If we have the square root of a divided by the square root of b, this is the same as the square root of a over b. This is the quotient rule for square roots. And we can use this to do divisions involving square roots. Let's look at just a couple of examples. Let's look at the square root of 6 divided by the square root of 54. Neither of these are perfect squares, so we can't evaluate them individually, but the quotient rule says that we can combine them under one radical as the square root of 6/54. Once we've done that, we can then reduce the fraction inside the radical. 6/54 is the same as 1/9. We can reduce the top and bottom by 6, and the square root of 1/9 is 1/3. So by combining these two into one radical, we could reduce and evaluate pretty easily. Let's do another one. Let's look at the square root of 24 divided by the square root of 2. Again, these aren't perfect squares, so we can't evaluate them, but we can combine them under one radical. And once we've done that, we can divide. 24 divided by 2 is 12. So we end up with the square root of 12. Now, this is not a perfect square, but it does contain a perfect square factor. We know that 12 is 4 times 3, so we can split this up. And when we evaluate it, we get 2 root 3, which is much simpler than what we started with. In general, having a radical in the denominator is very, very unhelpful. It's the last thing that we want in a problem. And the reason for that is because dividing by an irrational number is pretty brutal if you're doing it by hand, even if you're getting an approximation. So by combining these into one radical, doing the division, and then simplifying, we end up with something that ends up being much more useful to deal with.